Okay, great. All right. So welcome everyone. This is our December Christmas version of Tri-State Connect. The chapter organized this program so that we could reach out to people even when the winter weather is here and it's cold and icy and no one wants to go out to a support group meeting, so that we could have a virtual meeting right here in the comfort of your home. And that's where I am today. We were just talking about the Christmas season, and I was going to show, but you can look it up online. There's a picture of Rockefeller Center, and we are very proud to say that the tree from Rockefeller Center came from our area, about half hour, 45 minutes from Binghamton, New York, which is where the chapter is. The Tri-State chapter's mission is threefold. It is to support patients with scleroderma and their families, to fund research, raise money and fund research to find the cause and cure for scleroderma. So education opportunities, the third part, and education opportunities like this allow us to bring great speakers, great programs right to your home. So today is, our guest speaker, is Teresa Liu from the Hospital for Special Surgery. And I met Teresa when we did Kids Get Scleroderma 2, which turned out to be a wonderful event for kids and families in Hackensack. And she came to talk about research. And when I reached out to HSS for a speaker for this program, they both, Dr. Gordon and Dr. Spiro, suggested Dr. Liu to do this presentation. So there's always new and ongoing research that's being done at HSS, and that is in New York City. What Teresa is doing is looking for a possible mechanism behind fibrosis, and that has been a really big focus for Tri-State and the Scleroderma Foundation, is that if we can try to raise money for scleroderma, which partners with fibrosis, that partnership should help us to find more funding, because fibrosis is a common thread between scleroderma and many other diseases. And so Dr. Liu is looking for the mechanism that maybe one day we can eliminate or stop fibrosis, stop its progression, and it's really exciting research. So I'm going to turn this program over to her, and she will be able to take us through some of the work that she's doing.
Great.
Now,
thank you, Mary Beth.
You're welcome.
Okay, let me, show my screen.
Yes,
hold on, let me just get to my, okay.
I hear you, but
There we go. Are you seeing this?
I do. I see your presentation.
Do you see the slideshow? Okay, great. All right. Thank you, Mary Beth, for the invitation. Thank you for joining us. I would like to tell you about what's going on in my laboratory, and also to tell you about the bigger world of these adipose-derived stem cells or stromal cells and potential use in scleroderma. So the talk is about towards improving adipose-derived stem or stromal cells in scleroderma. So what are these cells? These stem cells are called, otherwise known as mesenchymal stem or stromal cells, and they have reparative and regenerative properties. Okay, so many people will call them mesenchymal stem cells, and this is a term that you might have heard. But technically, the definition of stem cells in the scientific world has very specific, parts to the definition, and so the people are generally migrating towards this terminology called mesenchymal stromal cells because it's more general. It describes what they are, which is a mixture of cells often, that some of which include the stem cells, but some of which include other types of cells which also have therapeutic value. So I would refer to them mainly as stromal cells, but sometimes I will say stem cells. I try to say both, and so everyone is on the same page with me. So these cells can potentially regenerate tissues such as fat, bone and cartilage, and they can potentially repair tissues by reducing inflammation and then improving blood vessel supply to tissues. They also have the properties that can be associated with suppressing an overactive immune system. And then people can obtain them from fat tissue, from bone marrow, even placenta or umbilical cord, or the gums, like our gums in our mouth. Okay, they can be from a variety of sources, and people are starting to inject them into people for a variety of conditions, including bone and cartilage repair, or used with the transplant of fat tissue for example, after breast cancer and there's breast augmentation, breast reconstruction, you can inject it with fat tissues for soft tissue repair. And then people are starting to use these mesenchymal stem or stromal cells to treat systemic autoimmunity. Now, what about scleroderma? So, certainly, the potential function in suppressing systemic autoimmunity would be good for scleroderma, but there's also potential use of these cells for ameliorating fibrosis, fibrotic skin, and maybe other organs as well. So there have been a few observational trials in small sets of systemic sclerosis patients in Europe in the last 4 years, and there they took the fat tissue and obtained these cells, the mesenchymal stromal cells from the fat tissue, and then injected them into the fingers and then the face systemic sclerosis patients, and they observed some improvement. Okay. Then there was a handful of patients in Europe where they also gave these cells in the bloodstream, so they delivered them systemically, and they felt that there was some improvement in these patients as well. So these observational trials generated enough excitement so that people are doing bigger trials where they're going to have a placebo group, a group of patients who don't get this, so that they can really compare this with the patients who do. Okay, and then they can really see, the clinical scientists can really see if this will really help patients or not. And so there's a current trial of local injections of these cells in the U.S. It's, right now it's occurring, and it's at the phase where patients have been injected with the cells, but now they're waiting for 6 months, and they're going to see if there was any effect. Now, okay. Okay, and hold on, I'm losing my, here we go. And so let me just tell you about what we've been doing, because we think it may be a way to improve the function of these mesenchymal stem or stromal cells if we're going to use them to treat scleroderma. And so this is our publication that's just came out in the Journal of Clinical Investigation, came out last month, and the title is Dendritic Cells Maintain Dermal Adipose-Derived Stromal Cells in Skin Fibrosis. So let me break this down for you. So the adipose-derived stromal cells, these are the mesenchymal stromal cells, but they're from adipose or fat tissue that comes from under the skin. Okay, and then we're going to talk about a type of immune cell that helps to maintain the survival of these guys in skin fibrosis. And so findings, basically, just to give you the bottom line is our findings have implications for how to better treat scleroderma and how to improve the survival of these mesenchymal stromal cells in scleroderma. But we really started sort of a step back by saying, well, what happens to these mesenchymal stromal cells in the fat with the fibrosis development in scleroderma? So, sorry. So this is a histology from normal skin. Now this is, I'm going to use mouse skin because we're doing experiments in mice, but it's very similar to human skin. And let me just show you, this is the epidermis, this is the top layer of the skin, this is the dermis, this is the bulk of the skin, and under the dermis there is an adipose or fat layer, fat tissue, that's called the dermal white adipose tissue, adipose here. Okay, and so there's adipose tissue under the skin here that contains ADSC. So these are adipose-derived stem or stromal cells. These are the mesenchymal stromal cells that come from the adipose tissue. I'm going to call them ADSCs here. And then, as we mentioned, they have tissue regenerative and reparative properties. Now, what happens with fibrosis? We induce fibrosis in mice, and these are models that all investigators use to try and better understand fibrosis. And so here you can see what happens with fibrosis. The dermis thickens, the skin thickens, and then there's also a loss of this fat layer, see right here. Now there's a lot less. So our questions were this. Well, since skin fibrosis development includes the loss of the adipose under the skin, what happens to these ADSCs, to these stromal cells? Are they lost in number as a tissue, adipose tissue goes from here to here? And then if so, what are the mechanisms that maintain the remaining ADSCs? So these are important things to understand, because if there's a loss of regenerative and reparative cells, that might help to explain why fibrosis is so recalcitrant to treatment. Okay, and then if we could understand what maintains the survival of the remaining ADSCs, maybe we can use that understanding to better treat fibrosis. And so first, we looked to see what happens to ADSC numbers with fibrosis induction. And here, to follow time, so we induced fibrosis in a mouse model by injecting something called bleomycin. And you can see days after injection of this bleomycin, in the sort of control mice, we have steady numbers. But with bleomycin injection, with the fibrosis induction now, we have a loss of ADSC numbers over time. These ADSCs show higher tunnel staining, and tunnel is a marker of cell death. So that means that these guys are being lost because they're dying off. Okay, and then we find that they have an increased level of this molecule called podoplanin, which is like a stress molecule. And so we know that these cells are dying and then they're stressed. So many ADSCs die off with the development of skin fibrosis and are in a stress state. So that brought up two questions then. Number one, what causes the loss of ADSCs with fibrosis? We don't know the answer to that, but we said, well, okay, we will have to do more research for that, but maybe we can understand what happens, what maintains the ADSCs that do survive in the fibrotic skin. What are the mechanisms that help to maintain those ADSCs? And to think about that question, we went back to a study that we published last year in an immunological journal called Immunity. And there we found out an immune cell type called dendritic cells maintains stromal cells in other tissues like lymph nodes, sort of like tonsils or spleen. Okay, and so we said, okay, well, you know, these kinds of cells, stromal cells and lymph nodes they somewhat resemble the ADSCs in skin. So maybe dendritic cells will also help maintain stromal cells, mesenchymal stromal cells in the fat and skin. Okay, so we asked that question. And so we wanted to know now, are the dendritic cells in the same place as the ADSCs in that fat layer in the skin? And here is a mouse model of fibrosis, and this white line marks where the adipose tissue is after the skin ends right here. Okay, and then if we go close up and we stain for these pink cells, or red cells, they are markers in the system of dendritic cells, then we see pink cells here, right, scattered throughout the adipose layer. So dendritic cells are also localized in the skin adipose tissue in fibrosis in the same place as the ADSCs. Now that's mouse. What about human? So if we look at systemic sclerosis patient skin samples, this is the skin adipose layer, and then we stain for markers of dendritic cells, these immune cells called dendritic cells, and we can see them as well here in the adipose layer. Okay, so in human systemic sclerosis, then there are these immune cells that could potentially modulate or maintain the adipose-derived stromal cells in skin. So then the question is, well, do dendritic cells regulate ADSC survival? So to do this, we induced fibrosis in a mouse model, and then we depleted the dendritic cells. We got rid of the dendritic cells, and we said, well, if dendritic cells have a role in maintaining the ADSCs, if we get rid of them, then we should lose ADSCs, right? So we depleted them here. We looked 2 days later, and then we found out we lost ADSCs with dendritic cell depletion. We lost about half of them, and they're more tunnel positive, meaning they're dying. So when we take away the dendritic cells, the ADSCs start dying off. The remaining ADSCs start dying off in the fibrotic skin. So dendritic cells then maintain ADSC survival in fibrotic skin. Now, how do they do that? I'm not going to show you the data. It's all published, but I'm going to explain it. And it's like this. So the dendritic cells, these immune cells that are in the adipose layer and skin, express a molecule called lymphotoxin, and then this stimulates the lymphotoxin receptor on the ADSCs. Okay, this causes the ADSCs to stick down harder and stay there, which helps to maintain their survival. Okay, and so then the question is, can we give lymphotoxin signal to improve the survival of the injected ADSCs? Because, if lymphotoxin helps to maintain their survival, what if we give the
Oops. right here.
Okay.
All right.
Okay.
So sorry.
Okay. You know what? It's going to be relatively short. I timed myself. Sorry about that. But, okay, great.
Okay.
So you ready?
Yep, ready.
Great. Okay. So in order to understand if dendritic cells could help to maintain these ADSCs in the skin adipose tissue, we first look to see if dendritic cells are localized where the ADSCs would be, which is the fat underneath the skin right here. So here, this is a mouse model of skin fibrosis, and this GFP in red here is a marker of the dendritic cells in the system. And you can see where the fat is here. There are dendritic cells here in the fat compartment. This is the close-up of the dendritic cells. So dendritic cells then are localized in the skin adipose tissue with the ADSCs. This is a mouse model. Now then the question is, are they localized there in human skin as well? So this is a sample of skin from a systemic sclerosis patient, and here the white marks the fat cells here, and so we're in the fat layer of the skin, and then here we stained for dendritic cells with another marker, also in red, and here you can see there are dendritic cells in the fat layer in human systemic sclerosis as well. So now dendritic cells are also localized in the skin adipose layer in fibrosis in human systemic sclerosis. So, okay, so we have dendritic cells and the ADSCs in the same place, but do dendritic cells actually help to regulate ADSC survival? Is there a cause and an effect relationship? And to do that, we have to ask, well, what happens when we get rid of dendritic cells? Because if they do regulate the ADSCs, then when we get rid of the dendritic cells, we should lose ADSCs. So here we use a mouse model again of skin fibrosis where we inject bleomycin for 21 days, and then at day 21, we deplete the dendritic cells and check 2 days later for the ADSCs. And here we see no dendritic cell depletion. We have this many ADSCs, but then when we deplete the dendritic cells, we lose about 50% of the ADSCs. And then these ADSCs are more tunnel positive, meaning they're actually dying. So dendritic cells then maintain ADSC survival in fibrotic skin. And so we wanted to understand how the dendritic cells can do that. And we published all the different experiments in the paper, but I'm going to show you the summary here. So dendritic cells make a molecule called lymphotoxin. And then this lymphotoxin stimulates a lymphotoxin receptor that's on the ADSCs. And then this lymphotoxin receptor stimulation causes the ADSCs to adhere more tightly to the tissue, and that helps to maintain their survival right here. Okay, so it's a dendritic cell adhesion survival signal. And the key molecule is the lymphotoxin molecule that is expressed by the dendritic cells. And so we thought, well, that's really interesting. So in fibrotic skin, the remaining ADSCs that manage to survive the fibrosis are kept alive by dendritic cells in the lymphotoxin that they express. Well, so that means that lymphotoxin is a survival signal. And so can we add lymphotoxin to injected ADSCs to improve their survival if we inject them into fibrotic skin for therapy purposes? So here's what we asked this question: can we give lymphotoxin to improve the survival of the injected ADSCs? And so here we did this experiment where we took mice with fibrotic skin, and then we injected cells that were not ADSCs, and we injected a control antibody. So it's just a not lymphotoxin signal, okay? And we have this much fibrosis still. Then we injected cells that were not ADSCs again. Now we injected something called anti-lymphotoxin beta receptor, which is a mimic of lymphotoxin. It stimulates the receptor here. And again, we don't get any improvement in the fibrosis. And then we inject ADSCs, but not a lymphotoxin signal. We don't get any improvement in the fibrosis. And now we inject ADSCs with a lymphotoxin mimic with this anti-lymphotoxin beta receptor. And now we get a thinner dermis. You can see this compared to this, compared to this, compared to this, right? And then we get a thicker adipose tissue layer here compared to here, barely anything, and barely anything, right? So this equals less fibrosis. So we think then our discovery that dendritic cells and their lymphotoxin helps to maintain ADSC survival can be turned around and used to improve the ADSC or mesenchymal stromal cell therapy. And so what is, where are we going now with this? Well, this is mouse skin, mouse system, mouse cells. So we want to know, importantly, does this work with human cells, right? If we take human ADSCs and inject them first into mice with a lymphotoxin signal, does it also ameliorate fibrosis? Okay, and since ADSCs are being tried clinically right now, is this a way we can improve this therapy? Can we add the survival signal, this lymphotoxin signal, to improve the effectiveness of the ADSC therapy in scleroderma? There's a related question because we're not sure, nobody is sure, nobody knows right now if scleroderma ADSCs from scleroderma in scleroderma patients will work as effectively as ADSCs from a different donor who doesn't have scleroderma. And so, being able to increase their survival and improve their effectiveness can make it so that it's easy for scleroderma patients to use their own cells, which is just easier to get as a source in order to inject it into the fibrotic areas. Okay, and then we would like to know, is there a subpopulation of these ADSCs that is most potent or effective? And we're working to understand if there is a subpopulation. We think there is. And then how do they ameliorate fibrosis? How do these ADSCs work to make fibrosis from here to here? Okay, and we are trying to understand that right now. So we think also, besides a method to improve the local injections in scleroderma, we can use this for other manifestations of scleroderma besides skin fibrosis and also in other diseases. So maybe this can be used to improve lung fibrosis in scleroderma. And then maybe this methodology could be used to improve bone and cartilage defects, to ameliorate, to fix bone and cartilage defects, or in diseases such as arthritis and lupus. So that's all. We thank you for your time, and we'll take any questions.
Okay, great. Can you hear me, Teresa?
Yep, I can hear you.
Okay, all right. When you were talking a few slides before about bleomycin,
yeah.
what does bleomycin, why you're using bleomycin here?
Oh yeah, that's a good question. It's used used widely in mouse models of fibrosis because we have to be able to induce fibrosis in order to examine the fibrosis. And bleomycin is actually used. It's actually a chemotherapeutic drug, okay, that people have found produces fibrosis in some people. And so when investigators started trying to find out good models of skin fibrosis to use, they tried to inject this bleomycin under the skin, and then that they found that caused fibrosis that looks a lot like scleroderma patients' skin fibrosis, and that's why it's widely used. The bleomycin itself will cause a lot of cell stress and cell damage in the skin, and then that causes the fibrosis.
Okay. Now that makes a lot of sense. Yeah.
Yeah.
Being non-research oriented, I was like, okay, what's the bleomycin all about?
Yeah. I know. And when we do animal models, it's always like, it's always a little bit, we have to get it to that state, right? Get it to the state where we want to study it. And I think that the field is very fortunate that that the scientists figured this out about 20 years ago, because it allows us to also control the timing, because the fibrosis onset is about at day 21, and that way we know we're studying certain phases, of the fibrosis onset, which is really helpful in trying to understand fibrosis development.
Gotcha. Okay, so that makes sense. Then, what will ultimately, when you have to learn whether this will work in in humans.
Mm-hmm.
And ultimately, like it would be a drug that would be introduced to.
Yeah. Yeah, I think it would actually be used to treat the cells that would be injected. So so right now, let me just go to here for a second. So right now in scleroderma patients, the clinical trials that are going on. So like if it's, let's pretend these are these are like patient samples, right? So what people are doing are injecting the equivalent of this. The cells that they're procuring from the fat, they do liposuction on patients' tummy, and then they get these cells from the fat, that fat tissue, isolate them, and then they inject them into the base of the fingers to help try to loosen the tightened fingers, okay, the tightened tissues. And so we think that if we can take this lymphotoxin signal and just add that to the cells when we inject into patients, that's the question. Would that be enough to prolong their survival and make them more effective? So so right here in the experimental system, we gave the mouse this mimic of lymphotoxin, but we'd rather not do that to people, because we don't want to give them a systemic drug if we can avoid it, right? So we think that if we can try to treat the cells itself, that would be exactly enough, hopefully. But we have to try it. But that's where we're going. We'd like to do that to minimize exposure of the patients themselves to a systemic drug.
That's great, because fibrosis and scleroderma, I mean, it occurs all over the body. We have, the eyes even, and things like people don't, maybe don't think about when they think about scleroderma, but
yeah,
I've heard
it's really all over.
Yeah, and I've heard.
Yeah, so you can, right, so there are different ways to view this. So ADSC therapy, the thing that was tried in some small European trials and that's being tried right now in the US is local injections, base of the fingers, and also they had tried parts of the face where there was a lot of, there's like sort of a lot of fibrosis, not exactly around the eyes or around the mouth even, but just, it was, I think it was more some of the localized scleroderma patients. They have, the specific areas that are fibrotic. And so they tried local injections, but it could be local injections in other parts, like you said, like the eyes are affected. You're talking about the eyelids, right? Is that what you're talking about?
Yeah, well, fibrosis actually, it could be affecting their vision because of pressure around the eye. But like in Facab, that might be something that this could be used for, to loosen up that morphia?
Yeah, exactly. Yes.
Right.
Yes, potentially. Yeah. And then there are trials going on. People are also very interested in using this sort of to give it in the bloodstream to have all over effects, So for scleroderma, it's really, scleroderma is skin fibrosis, and then it's this autoimmune disease as well, right? They're like autoantibodies, and like the immune system is revved up, in a way that is connected to the fibrosis in a right now poorly understood way so far, right? And so these cells, because they have the potential to modulate the immune system, if delivered in the bloodstream, they could also be used in that way. So that, we haven't tested that modality at all, but it's potentially, if we found a way to, basically, I think we found a way to prolong their survival, really regardless of how it's delivered, but we have yet to test that, but it's a good potential.
Wonderful. Gosh, yeah, all this.
We're very hopeful. Just a lot of work. We have a lot to do, which is good. We're really fighting. We're really fighting for trying to make things better for scleroderma patients, and so we want to try all these things.
Absolutely. So how
experimental waivers? Yeah.
How long has this taken for you to get to this point? Like, how long?
So this project took about a few years, like 4 years. We're more slow at first because we were searching around a little bit. We had to understand how to identify the cells so that we could count them, things like that. But once things got going, it's probably like more like 2.5 years, the bulk of the work got done at that time, because then we figured out, it's sort of like, okay, it's these cells and this is how we identify them. And then once we realized that they were dying, then we said, okay, well, we can base it on other work that we're doing and ask that question. So things have a way of, sometimes at the beginning it's a little bit of, you got to look around a little bit, and be open to things, and then you sort of think really hard about what you have in front of you, and then the things open up. It's like, oh, the data's trying to tell you something, and then you could just go full speed ahead.
Yeah, that's really exciting. Any of the work in fibrosis right now, it's amazing. It's truly.
Yeah. I think, a lot of people, a lot of people are paying more attention to fibrosis, which is really good because it's so important, right? And like you said also, when you were talking about funding for fibrosis research, for scleroderma research and, related fibrosis research, is that fibrosis affects a lot of organs in a lot of conditions. It's a very general sort of phenomenon in that way. And so, understanding more about fibrosis can help everyone, and then the specific diseases that are affected by fibrosis, such as scleroderma, or in lupus it's like the kidney, for example. Then everybody can use that knowledge from the general knowledge for their specific tissue that's being that's affected. So it's really good that people are paying more attention to fibrosis, and there's more research going on, and there's a lot of exciting research going on.
There sure is.
Yeah.
I don't know if there's any other questions that anybody would have, but
okay. Well, thank you for listening.
Thank you. We appreciate you taking the time to do the presentation with us, and we will have this recording uploaded onto our website. If you go under sclerodermatristate.org and go to our support group page, there is a box that says Tri-State Connect. It's way down the screen toward the bottom, and you can listen to this recording and any of the other recordings that we have available for the general public, especially our patients and families. So we thank you, Teresa, for all that you're doing in the area of research. I think it's exciting. It gives scleroderma patients as well as other patients with fibrotic diseases so much hope, and that's really important to the patient to keep them going.
Yeah.
Thank you very much again.
Thank you.
And that'll be it for today's program. We'll be back in January in the third Tuesday of every month at 2 o'clock to present another chapter in Scleroderma Tri-State Connect. Thank you very much. Have a great day. Merry Christmas. Bye for now.